Hey everyone. So today we'll be looking at 213 House Robber 2. After solving House Robber 1, let's try our luck solving the House Robber 2. And we were able to, I was able to solve House Robber 1 with the recursion using DFS like permutation, but I uh, it was It was not very intuitive how DP solution works. Like I saw the video from Neetcode, and after looking at that, like still, I think uh, it's a bit difficult to come up with such solution during interview. But yeah, like we are here to just practice and um, get that thought process going in our head so that when we see such problem, we can come up with such solutions. Okay, house robber 2. You're a professional robber planning to rob house along the street. Each house has a certain amount of money stashed. All houses at this place are arranged in circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have security system connected and it will automatically contact the police if two adjacent houses are broken into on the same night. Given an integer array nums representing the amount of money each house, return the maximum amount of money you can rob tonight without alerting the police. Okay, so the thing is, if we rob house first, we cannot rob the last house, and if we rob the last house, we cannot rob the first house. That's for sure. Okay, you cannot rob house one and so if we see the input 232, you cannot rob house one and then rob house three because they are adjacent houses. So three, rob house one and then rob house three, money is equal to three. The amount you can rob is one and three. Okay, got it. So in this scenario, so in the last question, what we did was from starting itself, we were calculating like all the houses that we can, like the maximum number of houses that we can rob from, and then we were continuing that ahead, right? So what should be done in this case? And we were storing them in the rob 1 and rob 2. So in this case, if we do that rob 1 and rob 2, but the thing is we cannot rob the house, the last house, then how can that fit? So let's see if we can solve it with the brute force. Okay, so if we have the second house, the last house, so first house, we select to, let's draw this out. Let's try to draw it and then see if that makes sense at all. Okay, let's go to Miro, then go here, see. So what do we have with us is 2, 3, 2. right? 232. Let's go here. Okay, 232 is there. Then for sure we know that. Okay, for sure we know that let's draw this decision tree. We go with 2. We go with 2, and here we go with 2. And sorry, 0, 0, 1, 2. So here we go with 0 index. Then we can drop. Okay, if we take 0, let's do it this way. If we take 0, then we can take the next element to be, so we cannot take the last element, right? Because we need to check if it is the last element, then we cannot we cannot drop that house. So we gotta okay. So let's say if we take on the first house, then we need to make sure that we are not touching the last element. Like we are not going to the last element. How can we make sure that we are not doing that? So we can have a formula, like if so last node would be 2, right? So but in this case, how can we make sure that there is a circle, that these guys are forming a circle 0, 1, 2, which has value of 2, 3, 2. So I cannot definitely rub these two. How would you do it? We are 8 minutes into this and we are literally going nowhere. Let's take a hint. House 1 and house n are adjacent. They cannot be robbed together. Therefore, the problem becomes to rob either house 1 to house n minus 1 or house 2 to house n, depending on which choice offers more money. Now the problem has degenerated to the house robber, which has already been solved. Okay, got it. So, okay, this is a nice hint. This is really a nice hint. What we can do is, okay, yeah, that totally makes sense. We can divide this to, um, sorry guys, getting a call. Hey guys, I'm sorry. I just got lost somewhere. Yeah. So three, two, three is there, and the next one would be three and two, right? Okay. This is a nice hint. So what if we do like this? Like we know how we have solved the problem from um, so let's say we have let our rob1 is equal to 0 and let rob2 equals to 0. I guess we need to traverse the element two times for let n of nums. What we need to do is let temp is equal to math dot max. Actually, for we need to do this if we select first house, then I guess we need to do this. So I is equal to 0, I is less than nums dot length minus 1, I plus plus. So doing this and doing this minus 1, we will be avoiding um, the last house if we are selecting the first one. So plus rob 1 and rob 2, whatever is maximum we are taking it here, then rob 1 is equal to rob 2 and rob 2 is equal to 10. Okay, and here we have to do if let first rob profit 1 is equal to rob 2 would be holding everything. So yeah, once we have this, we do not select the first house. Then what we need to do is, okay, for let I is equal to 1, I is less than nums dot length. So at this point we do not do plus plus, sorry, I minus 1, and then let temp is equal to math dot max nums of I plus rob1 rob2, then rob1 is equal to rob2 and rob2 is equal to 10, and then finally we need to return math dot max of rob2 and rob profit 1. So we also need to reset this guy here, rob1 and rob2 to 0, so that, yeah. Okay, let's try and run this. Okay, yeah, it is accepted. 3, 3, and submit. What if, okay, so is there a edge case that we need to follow? If um, nums dot length is less than 1, return it can be equal to 0. So if it is equal to 1, then at that point we can return num of num of 0, else if nums dot length is, so yeah, I think this should do it. Okay, num, sorry, my bad. Yeah, that should do it. Okay, cool. But I am still not like the idea of using this guy is still not completely with me. I need to go through a Neetcode video or something like that and then try to understand it. You know what? Let's do it together. We will see the video one more time and try to wrap our head around what is going on exactly. So let's view it on YouTube and let's see.
Okay, let's solve Leetcode 198 House Robber. In my opinion, this is such a good question to understand. Even though it's just an easy question, you can learn so much about dynamic programming from this problem. And you might already know, Google really loves asking dynamic programming problems, and if you want to get started on that, this is such a good question to understand. So we're basically given an array of integers, like many problems, and each integer represents a house, right? So this is a house, this is a house, this is a house. They're all houses and they're adjacent to each other. So it's basically a neighborhood. We want to rob houses to maximize the amount of money we can rob. So why not just rob all of them, right? Nope, there's a restriction. We can't rob two houses that are adjacent to each other. So we can rob this house, but then we can't rob this house, right? So we have to rob this one next, maybe, right? On the other hand, if we rob this one, we can't rob this one and we can't rob this one. It has two neighbors. This might sound really difficult, right? So let's just start out with the brute force approach. Let's imagine if we were trying to get every single combination. Okay, so the first combination is where we pick the first house, right? So let's draw out what the decision tree of that would look like. Okay, so our first decision was to rob the house with
What the hell?
value 1. Okay, so next we want to rob more houses, right? But we can't rob this one. So we have to basically get the max we can rob from these two. So does that sound kind of like a sub problem? Yeah, but we'll get there in a minute. So continuing on with just the brute force, right? Okay, so now we want to rob these two houses, right? Well, we can't rob both of them because they're right next to each other. So we can either rob house 3 or we can rob house 1. So this is the decision tree, right? And so along this path, so if we were to rob house 1, right? Let's say we went along this path. Then we can either rob house 1 and 3, or we can rob house 1 and 1. Obviously, we're going to choose this one because that gives us the total, that gives us the maximum, which is 4. Okay, but what if we didn't rob the first house? We decided to rob the second house. So that would be our other decision in our decision tree, right? Rob house 2. Okay, now we have not many choices, right? We can't rob house 3. So the only house left is house 1. So we rob that one as well. So if we went along this pathway in our decision tree, we would get these two houses robbed, and that's a total of 3. But we remember we found this, which was a total of 4, which is greater, of course, so that's going to be our result. Now, this is a very brute force approach. Imagine if we had more numbers here, right? Maybe a 3 and a 4, then we'd have to have like more paths in our decision tree. This could get very complex. So how can we improve it? Can we identify any subproblem? And the answer to that is yes. Let's take a look at the subproblem. So remember, we have two choices. We want to get the max that we can rob from this entire neighborhood. So the first choice is we rob from the first house and then find the maximum from the remaining houses, right? Imagine there's more houses here. There could be a 3, a 4, whatever, right? This is the subproblem. We're finding the max of a subarray of the entire array. The second choice we have is we skip this house, right? If we skip it, then basically we're saying, okay, find the maximum of the entire subarray, not including the first value. So let's actually write out the relationship if it doesn't make sense yet. So if we want to find the max we can rob from the entire array, we have two choices. Rob in this case indicates the max that we can rob from the entire array. So in our first decision, we decided that we were going to rob the first value. So array of index 0 plus rob the remainder of this blue portion of the array. So we're skipping index 1. We're going to rob the entire array from index 2 to the end. So I'll say n is the end in this case. So that's our first decision. If we decided to rob the first house, then we're going to break up the problem into a subproblem. Now we got to rob the remainder of that array, skipping one of the values. If we didn't rob the first house, then we simply only have the subproblem rob every house, skipping the first house. So we start at house 1, not house 0, and go until the end of the array. So this is the recurrence relationship. You might not know exactly what that means, but it's basically a way to break up dynamic programming problems. Notice the result of the entire problem depends on only these two. If we can compute these two, then we have our result. But notice each rob can be broken up into its own subproblem, just like we did over here. So let's actually solve the subproblems now before we solve the entire problem. Now I could do this in reverse order, right? I could say, let's find the max of this subarray, and so on. But it's a little more confusing to do that, so I'm actually going to do it in order. So let's start at the first house, like we've been doing. So if we rob this house, that's basically our base case, right? So we can decide to rob this house. In that case, up until this point, we could rob a total of 1. Okay, now we get to the second house. So what's the max we can rob up until this point? Well, we can decide to not rob this house and only rob this house if we wanted to. Or we can decide to not rob this house and only rob this house. 2 is obviously greater than 1, so I'm going to decide only to rob this house. Next, we get to house 3. This is where it gets interesting. So what's the max amount we can rob up until this point? So we have two choices again. We can rob house 3 and we can rob house 1, or we can just rob house 2. The max is obviously if we rob house 3 and 1, and in that case we'd get a total of 4. Now we get to the last value, 1. So we can decide to rob house 1, and if we did rob house 1, then we would want the max we could rob up until these two values, meaning we'd want 1 plus 2, because 2 tells us what's the max we can rob from these first two elements. We can't include this one because it's adjacent to 1. So one of our choices is 1 plus 2. That's choice 1. Or we can decide to not even rob house 1. We can just get the max of the entire first 3 elements, not including this one. In that case, we have what we would get from the first three elements right here. We already computed it. It's 4. So our choices are 1 plus 2 or 4. Obviously, 4 is greater, so I'm going to choose 4. That means we put a 4 right here. And this last 4 means that for the entire array, the max value we could get is 4 if we wanted to rob houses. So we can put a 4 here. But notice how we don't even have to store this entire blue portion. For each value, like for this one, 4, to compute this, we only need to look at the previous 2 results that we computed. And the reason for that is because we could either decide to rob this one and rob the remainder portion of the array, not including 3, in which case we'd have the value computed right here. The other case is if we wanted the max we could rob from the entire array, we could decide to not even include this and just get the max from these 3. And in that case, the value would be stored here. So now let's look at the code. Since we only need to maintain the last 2 maxes that we could rob from, we'll only need 2 variables. So I'll just name them rob1, rob2.
Okay, so
We'll initialize them as 0 because if we get an empty subarray, we
um, laptop is again going slow if I run anything else other than like YouTube or anything else. I guess I need to also watch some other um, tutorials. Okay, let's watch this guy. Um,
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today is the lecture 6 of the dynamic programming playlist. And the problem that we will be solving is house robber. Yes. Now this problem is quite similar to the lecture 5. So if you have not seen the lecture 5, I'll recommend you to go back, watch lecture 5 and then come across and watch this, because I won't be explaining this problem in deep, because this problem can be solved using the same technique that I have used in lecture 5. I'll be using the same code, just there is a slight moderation in the problem. So let's
How's it going, guys? Today we're going to be going over another problem, and today we're going over a Google problem called house robber. So today, guys, our problem is from Google, and it's called house robber. Our problem description says, you are a professional robber planning to rob houses along the street. Each house has a certain amount of money stashed, and the only constraint automatically given a list of knobs tonight, which again is how many to has $2 for $1. And here's another example if you guys want to kind of go through it and look over it, but we're going to start jumping right into the solution. So the idea here, guys, is that we want to rob these houses, but our only constraint is we can't rob any two adjacent houses. So what we really need to do is we need to calculate the maximum amount of money that we can rob up to any point. And so eventually, if we can somehow propagate the maximum amount of money to rob at the ith house, and our I eventually becomes the last house, then we will actually know the maximum amount of money we can rob without setting off these alarm systems, right? Or contacting or alerting the police. So I think a good way to think about this is just, okay, well, how much money can we make if we rob 0 houses? And obviously the answer is 0, right? And so we can kind of slowly build towards, okay, how much money can we make from 0 houses? How much money can we make from 1 house, from 2 houses, from 5, from 10, from 30? And eventually that will give us from n houses, right? So like we said, the amount of money we can make from 0 houses is $0. Now, what if we had 1 house, right? Well, that's pretty easy. We just rob the house, and then we're done, right? So it's whatever that house has. Now, what if we have 2 houses? That becomes a little bit more interesting, but it's still pretty simple. If house 1 has more money, we rob house 1. Or if house 2 has more money, we rob house 2. And now this is where it gets into the super interesting case. So the third case is when we have 3 houses, right? 1, 2, and 3. So do we rob the second house or the first and the third, right? So how are we actually going to determine what we rob and why? And so this is basically called bottom-up processing. And so this is a dynamic programming question, and the way we're going to solve this is called by using, and so this is a dynamic programming question, and the way we're going to solve this is called by using something called dynamic, the way we're going to solve this is using something called bottom-up processing, which is common in dynamic programming. And the idea here is that if we're asking for the answer to the nth thing, we can solve a subproblem that's smaller, say the ith thing first, and that will actually help us get us to the nth answer. So we're going to do it the way we just said. How much money can we get from robbing 0 houses, from 1, from 5, from a million, so on and so forth. So let's go through those cases now, right? So we said if nums is null or nums.length is 0. So again, this is the case where we have no houses. We can't actually make any money. So we would return 0. And now if we have 1 house, so if nums.length equals 1, we would just rob that 1 house. So return nums 0. Now if we have 2 houses, so if nums.length equals 2, that's not the right syntax, then we would return the max of the 2, right? So return math.max of nums 0 and nums 1.
Whoa.
Okay, so those are going to take care of smaller cases, right? And so now we need to begin building towards bigger cases. But these will actually still hold, right? So we're going to make a dynamic programming array now, and dp of I is going to represent the maximum amount of money that we can rob up to the ith house. So we're going to say int dp equals new int nums.length. And now we said, okay, the amount of money that we can rob up to the first house, right? So dp of 0, which is really, it's off by 1, but in this case we're really just saying the amount of houses or the amount of money that we can rob up to the 0th house. In this case it's kind of including it. Would be
So looks like my internet is very bad, so I need to do it alone. So see you in the next stream, guys. Bye bye.